That's right. This is ConfT with your SE, and I am your host, Bryan Young. We're back a lot sooner than I anticipated, but really super excited to be back. And we've got a great show planned for today. Today we're going to be talking about networking as a service, specifically with my friends here from Nile Secure. Now, full disclosure, I was introduced to these guys on my first day at my new role, which was about 3 days after the last episode was published, and I mean, my jaw was on the floor. I was blown away with the way that Nile is doing this, and I'm wanted to share that with, of course, you, the audience. And these were the guys that were there that literally made me just go, "What? You do it? What?" So, of course, brought the two best people to come in and talk about it, and looking forward to our discussion today. So, go around with the intros. Austin, why don't I start with you and just give us a brief intro?
Yeah, hey, Bryan, thanks for having us. My name is Austin Hawthorne. I run the Worldwide Solution Architect team at Nile Secure. Just a little bit about me. I've been with Nile for about 1.5 years. We'll probably get more into it through the podcast, but the company's been around for a little over 5 years. And been in the industry for about 25 years, former CCIE, been a pre-sales SE in the New York metro region for a long period of time, as well as running worldwide SE organizations at HP Aruba, Vectra AI, and now here at Nile.
Nice. So you've been around, what's going on, where the bodies are buried.
Been around the block a little bit, yep.
Nice. Awesome. Well, thanks for joining. And Michael, how about you introduce yourself?
Thanks, Bryan. My name is Michael Kowal. I'm a solutions architect with Nile. According to LinkedIn, I think I've been at Nile for about 9 months now. Before that, I was 17 years into a 3-year commitment with Cisco, and before that was also at a university. I have like 3 or 4 CCIEs and like some patents, and I'm published as well. And now I get to play at Nile with the enterprise networking stuff, which is cool. Before I did a lot with carrier routing. So thanks for having me on, Bryan.
Nice. Yeah, the carrier routing thing, man. That's that's a whole nother world. We many episodes ago, we had a gentleman by the name of what I know his last name was Vaughn. I can't remember his first name. But he came from the carrier side of Cisco, and man, it's just a completely different world.
Yeah.
So that's awesome. Gentlemen, thank you so much for joining us today. I guess the first question we'll start off with, and maybe Austin, I'll kind of bring this one over to you. But what is networking as a service? I mean, we always have a lot of acronyms in the industry, NaaS, and this is, I guess, NaaS, because there's 2 ways. But what is networking as a service, and how are we defining it? How are you guys defining it at Nile?
Yeah, I think with a lot of acronyms in our industry, Bryan, it really depends on who you ask. And, I think people have different reasons to define it different ways, and I think we've all done that. So let me kind of break that question in two. I'll break it out into what I think the industry thinks network as a service is, and what we at Nile are, bringing to market, and what we think customers expect, something labeled network as a service should be. All right. And if we look at, what the industry has defined it as, it's all over the place. We have some organizations defining their broadband as a service offerings as NaaS, right? And it's really just, broadband, right? Mm-hmm. We have some people redefining their outsourcing of IT resources as NaaS, right? But it's just outsourcing. That's been around for decades. We've got some people redefining managed services, with some leasing of hardware as NaaS, right? But it's just managed services and leasing and hardware. So you've got a lot of, people kind of, attaching to that 4-letter acronym, and they're doing so because anything labeled as a service is getting a lot of attention right now, right? And, we got to think about, why is it getting attention, which is driving a lot of vendors and providers to relabel their offerings and package them up and call them as a service. What is it that's creating all that buzz in the industry? And, the way I look at it and the way we at Nile look at it is like, let's rewind the clock, 10 years or so. We saw cloud adoption of storage and compute as a service in the IaaS and the PaaS type of formats really gain a lot of dominance in the marketplace, right? For the most part, there's not a lot of organizations that are really sinking a lot of time, energy, expertise, and budgets into building out their own data centers anymore. Right?
Right.
A lot of them have moved to, consuming storage compute from Amazon, Google Cloud Platform, Azure, et cetera. And the reason they're doing that is because essentially they've gotten rid of all the burden, all that complexity, all that cost, all the trade-offs, all the compromises, all the constant trying to keep up with all the patches, the upgrades, the tuning, the security vulnerabilities, the scaling, what have you, that nobody, if they're being honest, was really able to do it well because it's just impossible to throw, all the humans, the bodies, the expertise, and the budgets at it to be able to actually get, the true value out of the investment you're making to make sure that the technology is always able to meet your business needs. Essentially, those cloud platforms came out and disrupted that whole space and basically said, hey, you can have your technology that's always ready to meet your business needs without all of that burden, right? And by the way, you can align your spend based on how your business is performing, as opposed to having a bunch of sunk cost, even, and if your business is not performing as well and you need to contract, well, all that cost is still there. With cloud,
Right.
they disrupted that. So, and the same is true for SaaS, right? You look at Office 365, you look at Salesforce, you look at that. There's a lot of organizations now that are consuming applications as opposed to building and scaling their own for the same reasons. So I fundamentally believe that what the market expects from anything labeled as a service, and why anything that has those last three letters in their acronym is going to get a lot of buzz, is because fundamentally the market expects I should be able to get technology that's always ready to meet my business needs whenever I need it, without all of the burden, right, the cost, complexity, et cetera, and I should be able to align my spend to how my business is performing.
Right.
If anything labeled as a service fails to meet those two criteria, I don't think the market's going to really accept it, right? And we've seen, there was a report done by an analyst firm, a couple years ago that talked about this trend. They talked about how NaaS, quote unquote NaaS, is going to grow from 1% enterprise adoption, I believe, in 2021 to 15% by 2024, 2025. And that was big growth, right? Mainly for the reasons I just explained. But if you kept on reading that report, it turned a little bit glim, right? It basically said that, hey, it's going to fall off a cliff after that because the outcomes that those relabeled traditional offerings, are going to provide customers are not aligned to those two principles that they expect from anything labeled as a service, right? And, we're doing here at Niles, we basically said, listen, to deliver those two type of outcomes, you have to build something from the ground up that is built to actually deliver those types of predictable outcomes at scale, right, to the organizations that are out there. And only then, if you actually deliver those type of outcomes, will customers, see the value in network as a service and truly be, happy to invest in that in the long term. And traditional incumbent vendors, the previous one that I was at, et cetera, as well as the ones that, just commonplace, common household names, it's just going to be hard for them to adjust and deliver those type of outcomes at scale because there's a lot of tech debt, a lot of customers they have to keep happy, a lot of products, a lot of code versions, a lot of market demands, et cetera. It's just going to be hard to pivot, right?
Right.
So you essentially had to start with a clean slate to build this from the ground up to deliver that.
Yeah, because just hearing what you talk about, IaaS and SaaS, right? At the end of the day, those were much easier to implement because the whole idea is that you didn't have to have the application or the infrastructure for the compute, storage, whatever, physically on-prem. As long as you had an internet connection and you could connect to someone else's computer, basically, right? You could run that application or that infrastructure to put whatever other homegrown applications you had on top of that. The problem becomes when you're trying to do that exact same thing and deliver it on the network. Well, that's hardware that you need to physically have on site. And, as you said, all the common household names, right? Organizations have been building these networks from the ground up for many years, decades even, right? And they'll have that asset. I've seen Catalyst 4500 switches that have been running for a decade, right? They keep going. They sweat that asset. They keep it going. But it physically has to be on-prem. You can't just, connect to the ether and be like, oh, I have a network now. So I think that's kind of where the difficulty of delivering true network as a service, as it's defined by the other as a service offerings out there. And to your point, and based on what I already know from seeing your presentations a couple times now, that's why you had to build it the way that you did. So, Michael, did you have anything to add to that?
Yeah, I like what Austin said about what as a service brings to these enterprise or customers is that they are able to flexibly move their business in
Like ramp up or ramp down depending on the business needs.
Yeah. That all that tied into speed. Isn't that these as a service offerings are more componentized and failure tolerant, and what on the technical side, a lot of the benefits that people reaped from that was frequent software upgrades, fail fast, fix faster, shift left testing, A/B software rollouts, deploy fixes as soon as possible. And then the blast radius, right? That's what really changed is the blast radius with IaaS and PaaS and all this stuff. The blast radius really shrank. It became really small because we're able to build smaller systems. So I think, to sum up that stuff, it was really all about speed. And that's what we're offering there.
Yeah, and Bryan, you bring up a good point about, just to add, touch on something you just mentioned about, having to put something on-prem. That's the key challenge that, I think the market faces with delivering network as a service, right? Because to your point, it is different than those other, comparisons that I made with IaaS, PaaS, and SaaS.
Those all rely on the network already being in place, the network and
correct,
the connection out, which is still just a network, right? It's just someone else's.
Yeah, exactly. And, if you think about that, part of the model that we had to fundamentally bring to market was, if you think about, and just to kind of refocus, because this is also one of the multiple definitions of NaaS, we got to focus on what part of the network we're actually talking about. At least for Nile today, we're focusing on the LAN side of the house, right? So your wireless LAN, your LAN edge. We're also getting into the distribution side as well as some visibility, side of the house. We're about to get into the internet gateway kind of, component of it, but it's essentially the LAN side of the network, right? So whenever I mention NaaS or we mention NaaS throughout the rest of this conversation, it's going to be really the LAN side. But for that, somebody's got to go deploy wireless LAN APs. Somebody's got to deploy access switches, distribution switches, and any kind of tooling that goes along with supporting, that stuff. Mm-hmm. Now, with a traditional approach that's been around for the last 3+ decades, first step, I've got to figure out what can I afford, right? To go buy and deploy on-prem. Not only what can I afford, but what can I consume from an expertise and knowledge perspective to get here. And if we just focus on the cost aspect for a second, if any vendor is asking you to say, hey, tell me how many APs you need of which type, if we just focus on the WLAN side for a second, right away I'm like, hey, can I afford the best AP that has 3 radios, 4x4x4?
You're already doing trade-offs.
Right? I'm already doing trade-offs. Or, can afford the bottom of the line one or middle ground one. Can I afford a high capacity design or just a coverage design, what have you? And what that leads, by virtue of having a SKU for an AP that I have to put into a BOM and figure out if it fits into my budget envelope, right away that leads to, if I spread that problem across 10,000 customers, 50,000 customers, everybody's going to be a snowflake. And if everybody's a snowflake, not just from their makeup of their hardware mix, but also their software mix, also their configuration, also their use cases, et cetera, then there is no way you can deliver cloud predictability and scale to snowflake environments.
Right.
So
Yep.
Yeah, one of the first fundamental things that we had to decide to do is say, hey, let's take that variable off the table. We're not selling APs. We're not selling switches, right? I'm not asking a customer to fit the BOM into a budget envelope and then figuring out what, ultimately that as-built network is going to look like. If I could take that variable off the table, I can start to create environments that look and feel the same, right? From if I got the best AP with the best wireless design, with the best resiliency, with the best access switching it's connecting to, with the best distribution, with the best visibility, with the best management, and it's a common code version with a common set of optimized protocols across the stack, I'm now set up to deliver predictable outcomes at scale. It's beneficial for the customer because they get guaranteed performance without all the trade-offs, and it's beneficial for me because I can deliver those type of outcomes. So it's not exactly cloud-like, but it is in a way because, listen, storage and compute, You don't really know what's going on behind the scenes there.
You
But
have no idea what's
ultimately,
going on.
customer 1 to customer 10,000, it's all using the same servers, the same CPUs, the same RAM, the same storage, the same top of rack networking, the same et cetera, right? But with their own custom use cases on top of it. We're bringing that in a hybrid world to bring part of that on-prem for a customer.
And I want to touch on the second half of the name, secure. We're talking just raw connectivity, right? Just getting ones and zeros from point A to point B. But when you're going through a true network redesign, a network refresh, right, as a customer, and you're going through that process of, okay, what APs do I want? What model switches do I want? You're also looking at things like the feature sets that you can have. Oh, well, I'd like to go zero trust. I'd like to be able to put in, various security pieces in there and integrate with Radius. And, I've worked with various NAC solutions, obviously, one in particular over the last 7 years. And, every time I would talk to a customer about NAC, it was like, hey, it's a crawl, walk, run. Wireless, very easy to implement on wireless. But when you start doing the wired and you're doing full Radius integration there, and it's a process, and you need to have someone that knows what they're doing on staff. So you're right off the bat, we're making a ton of trade-offs and weighing things out. And unfortunately, security, where it should be first and foremost, is on that chopping block as well, where you're trying to figure out, is this something I can afford? Maybe not specifically from a hardware standpoint, right? Because hopefully all the switches that you're looking at have those capabilities, 802.1x, etc. But from a capacity within your environment, your admins, right? Do you have the expertise on staff to be able to implement, troubleshoot, and babysit this, right? Because when you start, that's the one thing I run into every single time when you start putting NAC on the switch. It's like a switch by its design is meant to pass traffic and not be restrictive, and now you start adding these restrictions in there, and it becomes a problem. It becomes something you have to constantly babysit. But this is where you guys come in, and this is where I was just like floored with the way you guys are doing it. But you mentioned about the access layer distribution piece. Where really is the demark in terms of where does Nile's responsibility end?
Yeah, so essentially what we put in is something called our Nile Service Block, Brian. Mm-hmm. So that Nile Service Block is essentially, from a customer's perspective, a wireless LAN, the LAN access layer, the wired access layer, wired distribution switches that uplink today into a customer's core routers, core firewalls, or any kind of edge device they might have, providing connectivity outbound. And we also include visibility sensors that provide proactive visibility into what's happening on the network and beyond, so we can reduce the mean time to resolution for any kind of tickets that might, any kind of issues that might pop up. So that whole stack is what's encompassed in the Nile Service Block. So what Nile does is we go in, as soon as a customer tells us a site, we kick in and basically do predictive surveys, on-site surveys, determine, we automate what the bill of materials is going to be. We implement some work orders to do their surveys, as well as install and activate that Nile Service Block into a customer's environment. And once we do that, they now have a network that they can do something with, right? And what I mean by that is, if we go back to that cloud analogy, let's just use Amazon, for example. That might not be the best example, but it's the same with Google Cloud Platform or Azure. You buy storage and compute from them. All of that stuff set up behind the scenes for you, right? And it'll scale to your needs and everything else, which is exactly what we do. You don't have to worry about all that burden, but they give you the control you need to build your custom applications and workloads on top of it. And they give you the visibility you need to support your custom workloads or applications. We're doing the same thing, right? Ultimately, once that network service block that Nile service block is up, we give customers their own tenant, their own view to go in and configure their custom services on top of it. That's their SSIDs, their segmentation, their security, their integrations with their firewall, their Radius, their DHCP, what have you, so they can build their custom services, whatever their custom, use cases are for their particular environment, on top of our network without all the complexity of having to jump into CLI and configure in IP interfaces, IP helper addresses, route redistribution, excuse me, authentication, protocols and, multiple authentication, first hop security, and all that stuff is gone, right? They just configure, let's call it, for lack of a better word, intent-based config. What do you want this network to do? Tell it what to do, it'll do it for you, right? And then we give them the visibility they need through the portal to support their users, devices, and applications, their connectivity on top of this network. The network's ultimately ours to support. When we talk about predictable outcomes and guaranteed performance, we back it up with financially backed SLAs where we have financial penalties if we don't meet, SLAs around coverage, availability, and capacity. And if we're not hitting any one of those, it's our responsibility to fix the network, to scale the network, et cetera. And outside of that, it's the customer's responsibility to, deal with the context that we would call around our Nile Service Block. The environmentals, the heating, the cooling, the rack, the power, the support their users and devices with the visibility we provide, support the integrations into DHCP or Radius, and then support the upstream connectivity into the routers, firewalls, or what have you. Which, by the way, I'm sure we'll pivot at some point during, this podcast back to the security point you made, but there's a really good advantage we have in our Nile Service Block that enhances a customer's existing security stack with those firewalls, but we'll touch on that a little bit later.
Yeah, that was the point when Mike showed me that I was like, wait, you're doing what? And I'm looking forward to getting into that a bit later. But all right, so you kind of mentioned the service block, the hardware. Now is this white box hardware? Is this something else that you guys have? Are you utilizing someone else's hardware? What are you doing?
Yeah, we're building our own hardware. We are using chipsets like from Qualcomm and Broadcom, chipsets you'd expect. Mm-hmm. But we are building our own hardware. And the reason we had to build our own hardware and our own software stack is because, again, we wanted to bring some homogeneous kind of approach to what that network stack is that we're going to deploy to customer environment. We wanted to be freed of those trade-offs and compromises. And we needed control to make sure that, we controlled the bugs, the vulnerabilities, the upgrades, the end of life, et cetera, et cetera, et cetera. So part of eliminating variables that we would have to deal with that create snowflakes that become, problematic to deal with at scale, we had to kind of, develop this hardware to have all the capabilities customers expect without all those trade-offs and compromises. So not only are we designing and building our own hardware using chipsets like Qualcomm and Broadcom, but we're also building in, you touched on security before, hardware-based MACsec in every single one of our network elements. Deep packet inspection in every single one of our network elements, our own sensors to provide a user-based perspective of the performance of the network. All of that's built into the hardware stack that we're developing.
Wow.
Yeah, I think to add that that this is really a license to reset the architecture, and to building our own hardware is actually paramount. We've seen in comparative, like what Austin was saying with the, if you compare this to like a managed service provider that has, they're kind of handcuffed to using some third-party hardware, they're in turn handcuffed to that vendor that they're deploying. Yeah, I'm Austin, you keep mentioning all these things and I want to interrupt, and there's like 3 topics that you touch on. I got to start taking notes. Cuz then I'm like there's like 3 like stories I want to tell and I've lost them all. Like cuz I'm like so scared to like cut you off and stuff.
No worries at all, Mike. I think we all love talking, so definitely interrupt me whenever. But one real quick thing, Bryan, just to close out the hardware thing, because I think Mike actually just hit on something that's a really important, topic. Ultimately, because we design, build, and control the hardware and software stack ourselves, we fundamentally control, the refresh cycle, right? With a true as-a-service model, customers shouldn't have to worry about end of life anymore.
Right.
You've been in the industry for a long time. We've been in the industry for a long time. I can't tell you how many customers are either bumping up or past end of life, end of support, end of development because the business decides to reallocate budgets elsewhere, right? As opposed to refreshing on the planned, refresh cycle for wireless or wired, and they're asked just to sweat the asset for as long as possible, right? But yet, by the way, the IT business initiatives don't stop coming, right? The businesses continue to move forward. So a lot of network teams are forced to do more with less. And, at some point, the equation breaks, right? Some business initiative, like I had a customer that was trying to roll out a new voice application across 500 sites. And, they were stuck in this cycle of not modernizing as fast or refreshing as fast as they would have liked. And they had a bunch of end of life, end of support, end of development equipment that was out there. And this new voice application that was planned to save this organization $20 million over 5 years failed because as soon as they tried to roll it out, 40% of the network wasn't ready to meet the demands of that new application, right? So a lot of unplanned upgrades, right? Unplanned spend, chipped away at that 20 million. A lot of productivity hits because that new voice application wasn't working effectively in 40% of the sites, which was impacting productivity, all because the network was neglected. And it's all due to that traditional approach and all those trade-offs and compromises that we talk about that happen, every day. The reason we couldn't, to Mike's point, and this is, I'm glad he kind of brought that up, that we couldn't just take, and we get this question asked a lot, whose network hardware are you using? Are you using Cisco? Are you using Aruba? Are you using Extreme? Are you using Juniper? We're using our own because if we used any of them, we'd have to deal with all the underlying complexity that's inside that network OS stack, and all the bugs, vulnerabilities, patches, upgrades, tuning, et cetera. But we're also dependent on their end of life cycle. With us, we define what the end of life is, and as soon as we define that, hey, we can't support what we've deployed out there, and customers still subscribe to our service, it is on us to go upgrade that stack for the customer, which means they are fundamentally out of the refresh cycle.
Wow.
Yeah, can I add that, Austin, you mentioned this term before, snowflake, right? So if you can imagine talking to different enterprise, class networks, the amount of features, their deployment, and all that other stuff that they go through in their networks. We saw, like in my previous role, like dealing with carrier stuff, we saw this kind of transition, not similar, but almost, where you had carriers building networks and they were buying big giant refrigerators, and these refrigerators support hundreds of features, and the chipsets would support queue depths and all this other nonsense. And then what happened was like the web scalers came in. And what you found with those networks were, I'm thinking of two. So the first one I'm thinking of, it was a worldwide network, millions of users, and their backbone, they deployed 8 features. That's all they needed. There's another one, the largest service provider in the world right now, globally. They have a certain part of their backbone. It's something less than 10 features that they deploy. So what happened there was they started saying, well, we don't need all of this hardware, and what you saw was the hardware shrink, the ASIC shrink, and all that other stuff. Now, if we look at the enterprise network, I think we're seeing something similar to that. When we take the existing, legacy switch or router that Austin had brought up, and you look at the software feature set, there's about 600 plus features in there. I looked it up the other day. And when you look at the typical enterprise and what it takes to deploy, modern applications, et cetera, it's less than 10 features that you need. Yep. So when you're able to build your own hardware and your own software, knowing that, and still keep up with the unicorn business requirements, that's, again, when you have this license to reset the architecture, that's what we get.
I had a customer many years ago now that they were looking at a network refresh, and we were looking at I'm trying to contemplate if I should mention the name, but a product from my previous organization that is mainly based in the cloud. We'll let you draw from that what you will. They were looking at that because of the ease of use, the low, IT number of IT people. Like, it just made sense. But we ran into a little bit of a stick in the mud where they were like, well, does it support EIGRP? And I'm like, well, no. And they're like, I'm like, why do you need that? Like, explain this to me. And they mentioned that they need EIGRP stubbing because of the phone system, and there was, multicast and this and that. And I'm like, well, hold on a minute. Let's see if that's still in use. And I think ultimately what we determined was it was a feature. It was something they had set up years ago to fix a problem that was no longer a problem because the architecture, the phone system, the technology had advanced, and we didn't need that anymore. And I know, Michael, you and I have had this conversation before where it's like you're putting all these configurations and features and everything, you're stacking on top of them to either fix old problems or to support legacy environments or features or whatever so that these things can still continue to talk. And it's a requirement of these other vendors to be able to continue to support that. You mentioned IP helper. You mentioned CLI. Here's one because I already know the answer, right? With CLI, what do I need to get CLI? I need one of three things. I need a console port, which is a physical access. I need Telnet. Hopefully I'm not using it, but I need Telnet to begin with, and I need SSH. Right? Those are three things from a security standpoint. They're all pretty bad, right? I mean, SSH is okay. It's secure until it's not, right? Until there's a vulnerability found. Now, and of course, because the Telnet and the SSH stack is built into that software stack, when a vulnerability is found, okay, we need to go in there, we need to fix that piece, we need to update that portion of it. We came across a lot of vendors across the entire industry came into this issue with the Log4j vulnerability, right? Because it was something that was buried in the software stack that all of a sudden it's like, hey, by the way, this is really bad. You need to go ahead and fix this. And of course, from the user standpoint, they're like, well, I am not using it, but yeah, the hardware that you're using is. So I say all that to say, to kind of lead to you guys, like this all of this is gone. You got rid of all of this because you don't need it. The complexity of having 600 feature sets and the snowflakes, which I love that description, that is what kills automation and true scalability. Because as soon as you run into, and I've seen this happen, right? I'm not picking on anyone, but I've seen this happen where they try to add automation onto these very, very complex systems, and they run into these kind of issues where, oh, I didn't expect there to be a semicolon there or whatever, right? Because you have to have that interaction between the computer, the AI, whatever, the web portal, and CLI, and there's always going to be problems. And the best that you can do is try to remove as much of those variables and complexity as possible, or try to make the software a little bit, better at handling the errors that it comes back with. But when you're talking about multiple vendors, multiple code revisions, it becomes
it's
almost impossible.
It's untenable at that point. And you touch on a lot of things there. Bryan, real quick, I want to touch on a couple of things because you made a number of really good points. Just to start on the automation bit, there's a couple thought exercises that, I think are valuable to kind of go through. If you think about what's driving the need for automation, and by the way, I talked to a large healthcare customer last year in our EBC, and they basically have an IT environment right now that no IT project gets funded unless automation is part of the project, right? If automation isn't in there in some form or fashion, the project's not going to get funded, right? But if you think about automation, you're basically acknowledging that the need for that is because, if we're just focused on the network for a second, the networks become too complex for human consumption, right? So how do I scale? How do I get the value out of this investment? Well, let me throw some automation at it. Basically, automation is added complexity. I got to have trained resources that know automation. Right. I got to buy and purchase and scale and lifecycle manage tools like Ansible, develop it. And then I've got to figure out what problems I'm trying to solve and then go develop, automation against those problems and those outcomes that I'm looking for. It's added complexity and cost on top of complexity and cost, right? Is that the right approach, right? We'd argue, that it's not, right? At some point, you've got to solve or eliminate the underlying complexity and cost, and then build in automation and AI where it's needed, right? With a cleaner slate, if you will, which leads to, and by the way, part of that is, to your point, eliminating configuration. Configuration is complexity. It's riddled with misconfigurations, areas for mistakes, whether they're unintentional or whether they're malicious. Right, your CLI example, by the way, your Telnet example, your SSH, you're sitting there telling that story, and I haven't really thought about this before, but the amount of configuration you need just to make SSH work, right? I've got to have an authentication
generate
server,
RSA key,
right? Generate RSA keys. I got to have an authentication server, which means I got to buy and purchase and deploy and configure something else to support those authentication requests and make sure that whole thing is secure end to end across every network element I have in my environment, and make sure nobody can get into the console port to circumvent that SSH config, et cetera, et cetera. Make sure that I'm patched on every code version across every network element and authentication system. system to make sure that nobody can take advantage of any vulnerabilities that might exist in that SSH, stack and radius kind of callback back to, or TACAX callback back to the server. That's just to lock down access to my CLI.
To do something that should be pretty, now, I wouldn't say basic or rudimentary, but necessary.
Yeah,
right?
Yeah. It's a great example, and my mind started going as you were talking through it. I'm like, well, I haven't even really thought about that just one aspect before. But here's the last thought exercise that I'll kind of throw out there that I think is an interesting one. And Mike started to allude to this a little bit, and you kind of touched on it a little bit more. If I brought, let's just say I had a classroom of 100 different network engineers in a room, right, all from different organizations, let's just say. And I said, listen, here's an exercise I want you to do, a homework assignment. I want you to design me a network. And you can do anything you want, any vendor, any protocol, any capability, any feature, any knob, whatever you want, right? But it's got to solve these 10 use cases, and they're all the same 10 use cases for every single one of those 100 network engineers. But you have to fit it in this budget envelope because we've got a budget, right? And you got to make it so it can be handed off to operations, and operations can support it. How many different network designs am I going to get? Right. By the way, the answer is at least 100. Right. The answer is probably way more than 100 because, listen, I'm a network engineer, and I overthink everything. Michael knows this, right? So it's like I'm going to go through. Well, what if this? What if that? What if I present this option? What if I present that option? And I'll probably come up with 100 designs myself. Right. Because I've got those variables of budget envelope and operations that I got to deal with. Right. But if the network was meant to just do those 10 use cases, which is what the customer needs to drive their business forward, then if I can eliminate the operational problem, if I can eliminate the cost challenge, right, why not just give a network that can, you can do that intent-based config on top of to deliver the use cases you need to deliver, what your business needs. Now can you sort of elevate yourself from an engineer that's having to deal with CLI and protocols and securing and patching and tuning and optimizing, et cetera, to more of an architect that just leverages a network that's ready to meet your business needs, and now you can drive successful IT business outcomes to organizations, right? And focus your time and effort there, which is ultimately what the network investment's meant to do anyway.
Right.
Yeah. And to add. I got to get my thoughts in order here.
Dude, you got to write this stuff down, man.
Yeah. To add to that, I like the term that you used, Austin, elimination, because I think before we even get into automation, I think what we do at Nile is we focus on elimination first. And back to your example of like EIGRP stub, Bryan, that you mentioned before. Like, for example, when implementing OSPF, we look at OSPF, the number of like knobs that you can tune on OSPF, there's about 30 of them across both address families. And, when you're implementing a stack, like to support something like a protocol OSPF, we look at these different features such as like not so stubby area, totally stubby area, virtual. Turns out that 10 of those knobs, they're not used today because they were built to solve problems in like the late 90s. These old routers that had small memory tables. So these features were implemented. Now no one implements them. Then you go across the board, like virtual link, you don't really see that in the enterprise as well. So you can start not only build a thin operating system, you can actually take it down to the protocol level and start to thin those protocols out. So you have thin protocols. And what is the benefit for that? I mean, there's less bugs that get introduced. Feature regression testing is very streamlined because there's actually one vendor that's famous for poor regression testing because there's so many features that when they fix a feature, something else gets broken. The chances of that happening in, for example, in a thin operating system is very low, very low. And then when you get to SIT testing or solution integration testing, that's also a breeze too. Because everything's homogeneous, it's the same environment. The automation system and the software is running across all the hardware components. And when you want to get a packet from the wireless over to the wired port, all that stuff now can be built, I guess, in this term that we use, digital twin. So you get this kind of network Jenkins workflow where we can build software, let's say we fix a bug, deploy it in a digital twin, and we run all these tests. And in less than a day, that can be done. Because I know existing vendors, it takes about 2 weeks to do that, just because of the size of code, the existing code base they have, the number of features that they have to support. And in order to do that, they have to build all these profiles. I'll give you an example of this. I want to test or develop a new QoS feature. In order to do that, I need to document what profile I'm going to match against that. So Bryan wants this shaping feature to be implemented. Well, is it going to be implemented on a main interface? Is it going to be implemented on a sub interface? Is it going to be implemented on a virtual interface? I need all of that listed out. So these, the snowflake plus the lack of elimination, you get this, time to market with bug fixes in weeks. Adding new features takes weeks. Solving and fixing bugs takes weeks. And when you thin everything down, now you get to this, point where it's in days, maybe hours.
Yeah, it's when you start fixing bugs, you can introduce new bugs, right? Because you don't know what's relying on the other thing, and it's just like I don't know what I know there's a legit game, but there was a game my kids and I like to play. I think it was Yeti and My Spaghetti. And you had this bowl that you laid across all these oddly shaped spaghetti things, and they rested across the edge, and you put this Yeti on top, and you'd have to pull each string out. And I know there's a legit adult version of this game that's probably from the 70s or something, but the idea is the same. You start pulling at those threads, and you don't know which one is going to let go because it's so complex.
Yep.
So reducing the complexity by thinning out the code, thinning out the features, and you can do that because the Nile Service Block is basically from your access side of your firewall all the way through to the access points. You guys have sensors, so you own the network from the client to the firewall, and then you have your data center hopefully off of a different physical or sub interface there, but because you're able to do that and have that full control, you can thin out the protocols, thin out the software, the OS, which makes the adding of new features a lot more agile. Bug fixes a lot easier to do, which now allows you to do, because you've done all that, now you can do the automation piece. Now you can do the self-healing portions that we haven't even touched on really. And that's the only way that you can do it, is to start from the ground up and, basically have ownership over that entire service block.
Exactly.
By the way, Bryan, quick sidebar. How
Yeah.
did I miss the memo about the black T-shirt policy?
Well, this is actually gray. It's just the camera's
okay,
white
I'm good.
balance is off, but yeah.
I think I'm going to lose some credibility with the pink polo on.
No, I'm just jealous that your setup looks much more professional than mine. Like, you look like you've been doing, like, I'm a host on your show at this point. It kind of looks
I'd
like.
rather have all the Steins in the background. I'm sitting there staring at those, just lots of questions.
Yeah, it's a conversation starter. Absolutely. I have.
go ahead.
No, it was just this is usually on camera, but because of the camera angle now, I had to change it. But this guy will actually display time and date and everything, but it'll also tell me the number of YouTube subscribers and the number of views on the YouTube channel.
Nice.
So
That's pretty cool.
That was a fun little project.
Oh, so Bryan and Austin, before we get into the security piece, I wanted to share a story that Bryan, you and I went through with Austin real quick.
Yeah.
Because I guess, Austin, you're going to talk about the security stuff, but Bryan and I recently were in the same meeting together. This was besides the one that you and I were in, Austin, with Bryan. And Bryan and I met with a customer, and two things happened that were pretty funny. The first thing was we're about to go into the security story. And you can imagine, Austin, you're like with your wife and you're watching this movie that you've seen before. It's really cool. And there's a really cool part coming up and you're like, hey, check this out. Bryan goes over. Bryan's like sitting there and he's like this, the customers, there's like three of them in the room and the one guy, Bryan's sitting here. Bryan's like, yo, check this out. And I was like, it was so cool. But then what happened was we go into the security story, right? And the one guy, he's managing the firewall and when we finished like the demo, I don't know if you noticed this, Bryan, but it was like this movie, The Prestige. I don't know if you've seen this movie Prestige with
I don't think I have.
so Hugh Jackman and Christian Bale. They're both magicians, right? So
Okay.
this is one scene in the movie where Christian Bale, he's doing these magic acts in front of this like audience, and Hugh Jackman, he's a fellow magician, but he's hiding out in the audience, and he's doing all these basic tricks, and everyone's like clapping, and finally, Christian Bale does this teleporting man trick where he bounces this ball, goes in this box, and he appears on the other side of the stage and grabs the ball, and everyone in the audience is like, "Oh, that's pretty cool," but the Hugh Jackman character, he's a magician as well, and he's like, "No. You don't understand what just happened here. Like, I can't figure out how that was done." I'm not going to spoil it, but that's what happened in this room where there were 3 IT folks, and the one guy who manages the firewall and all that, he's a security guy. He saw what we could do, and everyone in the room was like, "Oh, that's pretty cool." And he interrupted. He was like, No. You don't know what you just saw. Like, do you have any idea? And they had to kind of catch him up to what was going on. So it reminded me of that movie.
Yeah.
So anyway,
I thought you were going to say, like, I was getting nervous about the movie. I'm like, wait, so like you were the magician and I got all the guys' wallets?
No.
I didn't take their wallets. Yeah, no, that was fun because, you know, you could kind of see, and I think, Michael, the way that you handled that, the beginning of that meeting, you asked them a question of, you know, what do you think networking as a service is? And they gave 3 good answers, but they were very different answers. And it really, really showed that, like, you know, the concept isn't really fully formed in this industry. But if you take the last 3 letters of this whole thing, the as a service, and you look at software as a service, infrastructure as a service, and you see the commonalities there, it's like, okay, then if we were to really call this a true NaaS or whatever, right, solution, it has to fit that same setup. The whole as a service thing is automated, scalable, you know, completely, you know, I don't know what's underneath it, right? I don't know what's going on underneath. I just know that it's there, and I can scale it up and I can scale it down, and I have service level agreements in place to make sure that it's still running, you know. And as I said in the beginning, it's hard to do that with on-prem hardware, but you guys have done it. You guys have figured it out. Let's jump right into the security thing, Austin. Unless you had anything else you wanted to add.
I think security is a good place to go next, Brian, because I think you know all the things that we've done under the covers and the reason we've done it and the type of outcomes and brings to customers. I think security is a great example of that. So even though we're going to be talking about security, you know, it's the way we approach security and the outcomes customers can expect from a security perspective that further emphasizes, you know, our approach and why it's important and why it's differentiated from what others are doing.
Yeah, no, because it's huge. So on the, and again, this is why it's Nile Secure, right? The way that you guys are able to handle this traffic is much different than how you would do it within a traditional network. But I don't even want to start explaining. I don't want to ruin it. So I don't know, Michael, Austin, whichever one of you want to take it. I want to go through kind of the same thing. I think, Michael, you showed in that first meeting with where you guys were showing it off to me at Driven. Let's kind of go through that and how the traffic flows through the Nile Service Block.
Yeah, Brian, I'll start off and then hand it off to Michael,
Cool.
and he can kind of clarify some of the things I'm saying, add some other kind of comments and anecdotes and the like. But I think it's important to start with the problem statement. I think trying to secure, again, where Nile's focus today is on the network edge. Trying to secure that network edge is I wish I had a more powerful word, but it's difficult. I don't want to say it's impossible, but it's difficult. And like you, having worked with a radius/NAC, solution in your past, when I was at one of my previous companies, I actually built an SME team and helped build a go-to-market around our radius/NAC solution. And at the time, I thought it was the greatest thing since sliced bread. I was like, this thing can stand on its head, do flips and twirls, and solve any objection or pain a customer had. I'm like, yeah, I can make this thing do that. What I didn't realize at the time, though, was it's complex beyond belief, right? And if you think about, and I'll give a little bit more anecdotes around that, But if you think of the job of the security team versus the network team, and I think, it's commonly known that a lot of those two teams don't necessarily work well together most of the times, right? And there's a reason for that. One, the job of the security team, just to boil it down to its basic, is to reduce risk in an organization, right? So they'll come up with standards, approaches, et cetera, and then some of that gets handed over to the network team. Hey, we want you to implement .1x. We want you to do authorize every device. We want you to encrypt traffic. We want you to segment this way. We want you to do X, Y, Z. The network teams get that and go, hey, I've got 100,000 switch ports and a bunch of APs and all this other stuff that I've got to operationalize and minimize the number of tickets and make sure that productivity doesn't take a hit so the network works for the business users and the business, and it's just up and operational and available all the time. Operations is their key focus, right? Not that security isn't, but operations is paramount because that network has to be always on and operating, for the users and the devices to keep that business moving forward. Adding complexity into that world, new protocols, which requires more regression testing, which requires more features, which requires more config, et cetera, just from a pure engineering perspective. But then it requires operations to have to deal with that complexity, and it causes user experience issues as users have to go through that complexity. Most network teams resist a lot of that, right? And they'll just try to do the fundamentals that reduce the amount of complexity they're introducing, but it becomes a risk versus complexity type of trade-off. And ultimately, that divide has been causing, the world that we're living in today. If you look at, what a lot of customers are struggling with, they try to close that gap with cybersecurity insurance, right? Hey, we'll put in some mitigating techniques. We'll determine what the cost of mitigation is versus what our risk of breach is and what the cost of breach is. And, a lot of CISSPs get paid a lot of money to figure out what that equation is. But you close that gap with cybersecurity insurance. But 5 years ago, that might have been an easy equation, right? The page of requirements from an insurance provider was probably about one page of checkboxes, and they were relatively gray, right? But because, you see all these breaches happening day after day after day, that one page of requirements in the last 5 years has gone to 40 pages of very strict requirements, very black and white requirements.
Right.
And cyber insurance premiums, I'm hearing from customers, and this is straight from customers, are going up 100% to 400% year over year if, and it's a big if you can actually get insurance. Because depending on those checks on those 40 pages of requirements, if you can't check off enough of them, they're not going to insure you, right? Because insurance companies are in the business to make money, right? If they got to pay a lot of insurance because people are getting breached, it's a problem, right? Yep. So something's got to give, right? So ultimately, what we set out to do is say, and by the way, a lot of organizations have given up. They've moved security elsewhere because they realize that it's almost impossible to kind of balance that trade-off between risk and complexity and trying to lock down the network edge. So that's a big problem that we set out to solve, right? Another big, but if, for customers that are doing, or trying to secure that network edge, if you look at the common paradigms that they're using, VLAN-based segmentation, right? A lot of customers are basically saying, hey, listen, let's segment different types of users and devices based on their risk profile into different segments, which is traditionally a VLAN on a network, and let's trunk up that VLAN to a firewall, and let's do some policing at that firewall.
Right.
Listen, VLANs were never made as a security container, but they've been overused as a security container for way too long. And one problem that gets accepted, not overlooked, but gets accepted in most organizations is, hey, there's no point of security until you get up to that firewall. Yes, you have these devices segmented from these devices or these users, but if a compromised host comes into an environment, and by the way, most security experts today will plan around assumed compromise. You're not going to prevent everything. So you get a compromised host come in the environment. That compromised host is going to be able to laterally spread to every other host on that VLAN without the firewall being able to see or do anything about it. Right? And that's a problem, right? I've just introduced more risk in my environment, and okay, maybe that's acceptable because maybe I'm going to try to catch it before it hits my critical asset and become a breach, but I've just increased my blast radius because of this trade-off, right?
There's still a lot of work to be done when that happens.
A lot of work, right? And, the other trade-off is a lot of people will put some level of security onto their wireless network, strong encryption, strong authentication, et cetera, because they know that that wireless is going to leak out the physical boundaries of their building.
Right.
But the wired network, going back to that security team versus network team and their careabouts, the wired networks, do I incur all that complexity on the wired network if I still have physical walls and a lock on the front door? Or do I just leave it as is and let me just map a port to a VLAN and color code the port and hope that I plug the right device into the right port to get the right security policy up at the firewall? Right? Am I going to go as far as to do dynamic ACLs or roles or private VLANs or VXLAN or firewalls all the way to the edge of the network? Most organizations don't.
They don't. Yeah,
Right.
they don't. They don't have the time, the budget, the expertise in house to do it, and that's ultimately the problem, right? And many times I've gone to customers and been like, "Hey, we're in a conference room." When we used to go to conference rooms, which I'm glad we're going back now. But you'd be like, "Hey, what happens if I plug into that network jack?"
Yep.
And if they even know what happens, it's still not good, right? It's like, oh yeah, that's you're gonna get on our network, and to all the points you're saying, these technologies, these security features, they exist. It's capable. You're capable of doing micro segmentation, to bring that blast radius down to 1, right? Instead, but who is going to go through the traditional kind of setup and be able to set that up in a way that is not intrusive into the environment, right? And this is why the networking and the security teams, right? One's trying to increase access and one's trying to decrease access, and that's why they bump heads.
Yeah. So what we wanted to do is we were like, listen, can you have your cake and eat it too? To use that analogy, right? So
I like
ultimately,
cake.
if we purpose build a network that's built off of zero trust principles, right? And zero trust is getting a lot of play lately, right? As opposed to NAC. So let's focus on zero trust for a second. There's a couple of zero trust principles that are paramount to organizations that buy into that construct. One is you need to encrypt end to end, right? Number two is you need to ensure that every connection is authorized. And number three, you need to ensure that every request is enforced or authorized as well, right? So if we focus on those three principles, one, we've built in MACsec, hardware-based MACsec, end-to-end by default in the entire stack. No configuration, hitless key exchanges, right? Nobody has to touch it. It just happens by default. And by the way, getting back to the config, analogy that you brought up earlier, Brian, the fact that nobody has to touch it means there's no misconfiguration and there's no ability for somebody to maliciously circumvent the configuration, right? We have no CLI. I don't think we explicitly said this before, but there's no console ports, no CLI, no telnet, no SSH, nothing on our boxes, right? So no ability for somebody to make a mistake or to circumvent a control. So if there's end-to-end encryption in that whole stack, that means there's no ability for somebody to do any kind of man-in-the-middle, active or passive snooping, IP packet injection, et cetera, right? There's just zero capability to do that, right? So that's number one. From that initial client connection all the way up to the firewall. Number two is we don't allow any unauthorized connections onto the network. So we can tie into your radius server if you want to do radius or NAC, we can tie into that. That authorizes some connections. We can do, PSK, UPSK, device registration. We can do captive portal. We can do SSO. All of those things can authorize connections onto the network, both wired and wireless, which, by the way, every single one of our wired ports are automatically configured, to do multiple types of authentication, .1x, MAC-off bypass, SSO on every port, so you can plug any device in anywhere. And that essentially gets rid of that open ports mapped to VLAN. You hope and pray that you plug the right device into the right port. By the way, quick sidebar, I was talking to a customer that had, I think, 114 different sites across the world. They just spent 5,600 man hours to deploy the golden config onto every one of their wired ports to do those three types of authentication so they can have a colorless port type of concept in their environment. Right. And by the way, that was a one-time effort. Now somebody's got to maintain, troubleshoot, and operationalize that config, right? That's
God
all.
forbid they ever need to expand that VLAN to a larger subnet size.
It's crazy. So, yeah, exactly. So, we've eliminated that. And even if a customer doesn't want to do any kind of strong authentication on a wired port, we still have the capability by default to kind of follow this zero trust paradigm of no unauthorized connection. You must, in our world, authorize a device or a group of devices and authorize them to a segment, right? An IoT segment, an OT segment, an employee segment, a staff segment, whatever. And then only then can somebody plug into a wired port and they get into any port and they get mapped automatically to the segment that they were authorized onto. This has also essentially eliminated shadow IT, which is a big problem in organizations, right? Some business unit buying a device and just plug it in a network and hope it works, right? But, I was talking to some people internally here and we're trying to figure out how many customers likely know all the devices that are plugged into their network. And I wouldn't say it's the majority, right? So with this, you absolutely know what's plugged into your network and you have full security control. Now, the last piece of that zero trust paradigm, and I'm going to hand it over to Mike so I can take a breath and have Mike add some additional color commentary, is this authorize every flow or authorize every request, right? And this is where we get away from the VLANs being overused as a security container. We still allow customers to segment the way that they want to segment, with whatever subnets, mapping users into IoT, OT, staff, student, faculty segment, what have you. But we go a step further by default. Again, no configuration. Inside that segment, inside that subnet, we then isolate every host from every other host by default, encrypted end-to-end up to the firewall. So the firewall now has the ability to see and enforce every flow from every client, even if they're talking to each other on the same subnet. I have now just, to use a word of one of a contractor we brought in to help with white paper, I've now supercharged that firewall. The big security apparatus that companies have operationalized a lot of the security controls around, I've now enabled that firewall to see and do more and truly be able to limit the blast radius of a compromised host to 1.
You've put that firewall in the middle of east-west traffic.
Yep.
Because that's ultimately the problem that's faced with most organizations that I've spoken with, right? Is they have the firewall to monitor the north-south, but they're losing they don't have that visibility on the east-west, and they don't have those controls, or they have limited controls because as you said, right, you have your traditional networking setup, right? You have your VLANs and you say, okay, this is my HR VLAN, this is my IT VLAN. I don't think anyone really deploys them like that, but that's how they have them set up, right? And the idea is that if you want to talk VLAN to VLAN, it's going to go up to the firewall, and the firewall is going to be able to make a decision. Maybe you have ACLs in place, maybe you don't. And again, if you make any changes to those VLANs, you increase the subnet size from a /24 to a 23 to make room for more devices. Now your rules have to change. And if you have ACLs on 20, 30, 40 switches, good luck. Have fun. Hope you don't forget anything. And that creates the complexity and the problem. But you're saying to me here in the Nile segment, in the Nile Secure Block, did I say it right? Nile Secure Block.
Nile Service Block, yeah.
Service Block. I'm like, I knew that wasn't right. It's the Nile Service Block. 2 devices on the same segment, on the same switch. One's plugged into one port and one's plugged into the other. Their communication between the two of them does not switch on the switch itself. It goes up to the firewall.
That's correct by default. And this is a really important point. So I want to double click on this a little bit. So that is the default behavior, Brian, because again, if customers have invested so much time, effort, and expertise and cost into their firewalls, right? Let's enable that firewall to do more instead of trying to bring that complexity all the way into the network stack, which fundamentally, I don't want to call it a failure in the last 2 decades, but it has not been widely adopted in the last 2 decades. So let's bring it up, the traffic up, as opposed to trying to bring that complexity down. That is the default behavior. But I mentioned it's the default behavior because there is options, right, to allow that local switching, if you will, to happen on a per segment basis if a customer wants to. Now, the common question we get when we bring this up, besides the big security advantage to it, is this going to overload my firewall?
I think I
Well,
asked that question.
Yeah. And by the way, it's a common reaction to this type of architecture.
Right.
Now, I will tell you that in most, if not all, of the deployments that we've done so far, the answer is no, right? And that's because most of the traffic today is north-south anyway.
Right.
Yeah, we've
Right.
we've looked a lot into that. Where I mean, if Bob and Alice, we've talked about this before, Brian. Bob and Alice are collaborating. There's no longer this peer-to-peer collaboration, right? This is all cloud, O365, SharePoint stuff. There's other applications like telephony. There's a trend where telephony is now becoming cloud-based, so that's becoming a north-south thing. Printing, we've looked into. I mean, you depending on the size of a PDF something's printing, it's like 3 or 5 meg traffic flow. The one heavy hitter still is the beefier machine to machine use cases such as like IP cameras that are doing like high def. That's probably a use case where you'd want to do local switching. The other machine to machine stuff that's measured in the kilobits. Ironically, of all the customer deployments we've had where we've seen like what application is the heavy hitter when it comes to east west, it's not the cameras. It's actually malware. Ironically, we had this. There's a story where we had one customer, and they're in the EDU space. They're a university where someone comes in. I'm not sure who it was. It may have been a student with an infected laptop that had ransomware. And what it does is that they plug into the legacy network, and I think what the malware did was it spawned something similar to like an Nmap scan, and what it does is it threads them. So instead of I'm gonna scan a couple IP addresses, it would thread a scan per IP address. So if you looked at the network traffic utilization, it would be 20, 30, 40 meg coming out of one device, which is not typical.
Right.
And the way that they found this issue was, number one, they saw this utilization, but it didn't. It was kind of like a needle in a haystack. Humans see these charts, kind of go up. It was almost a blip, but 2 of the servers got compromised. Right. It's like this splash screen where they can't. It's like, hey, you've been hacked. Here's the Bitcoin address or Ethereum, whatever they're using, and we'll unlock it for you. This user brought his network, his PC or his laptop over to a different building that they were using a Nile-based network inside of this building. So they called us and said, hey, we want to understand the impact it had on this building. And we said, that's easy. Go to your firewall. The blast radius was 1. And actually, their firewall caught this because they had a threat protection profile that was there, and it was a TCP-based attack, and it actually detected it, and if it detects it, it blocks it. And they're actually able to see in their log that it stopped it and who this IP address was, etc. So that was pretty interesting.
That's incredible because absolutely necessary for the firewall to be able to guard against things like port scans, right? Because what is the firewall probably going to see when it comes to guarding against port scans? Most likely, what it's going to see is from the outside coming in, right? My firewall sees stuff all the time, and then you've got some geo-blocking rules and stuff like that, and it's meant for that outside facing in. But I've said this 1,000 times in my years now doing this, that the whole idea of the network just being the hard outer shell with the soft gooey center, it doesn't work anymore because there are so many attack vectors out there. Laptops or devices are leaving the network and coming right back in. I would ask that question to my customers all the time, be like, what percentage of your 1,000 users or devices on your network are laptops? And they're like, 60%. I said, well, 60% of your devices are walking around your firewall as they go out the door. So you have zero control over them when they're off the network, and of course there's things in there, but what happens when they come back? And to that point too, if you can put in those additional features of being able to detect and stop port scans from inside the network, that's hard to do on a firewall unless you're going in a traditional network, unless you're going across VLANs. But with Nile here, because all that traffic is being sent up there, even if you're trying to scan your own subnet, the firewall would be able to catch that and be able to block that. So we touched on a couple really good points here. Sending all the traffic, even traffic within the same segment, and we're very careful, I've been noticing, to call it segment, not VLAN. We'll call it subnet, we'll call it segment, but we're not calling it VLAN. So we're not worrying about VLAN numbers. We just want to know what's the subnet, what's the size, what's the name of the segment. Name, not number, nothing crazy to remember there. Oh, now I lost my train of thought. So all the traffic that's going up, in between segments is being sent up to the firewall. The concern, of course, is that going to add the additional, strain to my firewall as it's configured today? The answer, most likely not, because of X, Y, and Z. Maybe the one kind of, machine-to-machine kind of setup you'd probably be looking at to consider doing interswitch switching would be something like cameras, because it's just a constant stream and the firewall doesn't need to be dealing with that. There's ways to circumvent that too. Maybe your cameras are on a different physical network, whatever. And of course, you can always put trust in the firewall. But maybe you want to scan that traffic. Maybe that as the camera, maybe that's also a possible entry point for an attacker, a pivot point for them. So something to be weighed out. But what you guys are giving the customer is basically all those 3 points that you mentioned with the true zero trust networking, end-to-end encryption. Every connection is authorized and every request is authorized. You're bringing that to the customer right out of the box.
That's correct.
With the exception of a radius server that you have to connect to and a DHCP server that you have to tell it to point to, there's nothing outside of this that's necessary.
Well, actually, even on that piece, Brian, the radius and the DHCP, good pivot.
I forgot about that.
I don't know if you did that on purpose, but it's
not initially, but I'll take the credit for it.
You guys call each other before meeting?
Now, listen, let's rewind a little bit to the initial part of this podcast. We were talking about, the different definitions of NaaS. Another, acronyms that has been defined a multitude of different ways in the last 20 years is NAC, right? Mm-hmm. Network Access Control. And I competed in that space for a long time, and I've competed against indirect and direct competitors that had different interpretations of what that means. Mm-hmm. And ultimately, it's on the customer to define what that means for their particular use case, their risk tolerance, that trade-off with operations, et cetera, that kind of goes in, right? I don't think there is one definition of what does NAC mean for every environment.
Right.
Ultimately, if you boil it down to its basics, it's authorizing devices and segmenting devices based on risk profile, right? Mm-hmm. And if we boil it down to that basic definition, does a customer actually need a separate radius or NAC server in a Nile world? If we're providing capabilities inside the Nile network itself that, can authorize devices by a MAB type approach, a MAC auth bypass type approach based on MAC address, OUI, or even fingerprint, and you can authorize devices into segments based on those variables. Hey, that could be a type of NAC for somebody's wired network if they want to do it that way. We integrate with SSO, SAML 2.0. What if you start treating the network as an application, any other application you have in your environment that you're using SSO to authorize connections to, and just bring that same experience and that same repository, right, to the network, and then start authorizing users onto the network, wired or wireless, with SSO. That's a form of NAC, mm-hmm. right? What if I use captive portal for guest? What if I use fingerprinting for this other, capability? What if I use device registration for this other use case? All of those things can be a NAC for an organization, right? If customers fundamentally believe that, hey, I absolutely need 802.1x with EAP-TLS, for example, which is, what I would consider probably the gold standard for network authentication, encryption, what have you. We even have a capability coming out soon, right, where we're going to be able to do radius as a service within the cloud, right, to be able to do that EAP-TLS type function, right? And that gives those NAC capabilities without the need for an external radius server, right?
Wow.
Which further enhances our TCO and ROI equation to customers because it reduces more cost and complexity in their environment, right? That said, we can absolutely tie into the existing, radius NAC infrastructures that they have today. That'll be out soon, but one thing we absolutely have, another thing that you mentioned is DHCP, right? We can tie into customers' Microsoft or Infoblox DHCP servers that they have today, but if that is cost complexity that they want to get rid of, right, we have a DHCP service available today, right, that customers can opt into, right, which eliminates that cost complexity. It's built right into the cloud, right into the Nile Service Block itself, so that goes away. One other thing I think that's important in this part of the conversation is, especially if we're talking about NAC, we brought up zero trust before. Those two concepts have sort of competing a little bit. And I think, frankly, zero trust is winning out. But zero trust has been primarily relegated to the remote hybrid workers, people running an agent, on their laptops and, proxying their traffic to these cloud security providers like Zscaler, Netscope, Prisma Access, Cloudflare, et cetera. But it hasn't been widely adopted at all into the network stack, into the campus environments, right? So the next big step is going to be something that I think, some analysts are calling campus ZTNA, that when combined with the remote access, it's going to be called universal ZTNA, which basically brings that ZTNA constructs to the network layer, right? And by virtue of how our network works, where we're doing this host-based isolation, encrypting end-to-end, authorizing every flow, we can now start using that to not only push traffic to the firewall, but what if the firewall is replaced with something like a Zscaler, Netscope, Cloudflare, Prisma Access, and now we can intelligently route traffic right up to one of those ZTNA type of providers. So you have a universal ZTNA construct in your environment.
Wow. It opens up all sorts of possibilities. It really does. Absolutely incredible. I still have so many questions, and I just looked down and realized it's been an hour and 17, and it's funny to think. I used to think this podcast would only be 20 minutes an episode. I mean, real quick, I think there's two things we need, or at least there's one thing we need, no, two. We need to touch on two things before we wrap this up. We've been talking about the as a service piece. I think it's, kind of been mentioned and discussed, but let's kind of understand the payment models, because I believe you have two, right? Can we dive into those just a little bit at a very high level? I don't want to get too much into the weeds.
Yeah. At a very high level, I think I mentioned this earlier, Brian, we are not in the business of selling hardware, right? So customers are never going to see a bill of materials from us, right? We design the network to make sure that we build in all that resiliency and scale and capacity, et cetera, to deliver those predictable outcomes. We don't want there to be an upfront cost that leads to trade-offs like we talked about before. So there is no SKUs for APs and switches and everything else. Essentially, it's a service. Customer tells us a site, we figure out the square footage, and then we present two different options for customers. Excuse me. One is a very simple, predictable pricing schedule that is purely based on square footage. They'll get a price per square foot, and the rest is handled by us, right? Customers love that simple option because ultimately it's easy to budget for, it's easy to understand, it's easy to predict cost as they scale up, as they scale down. As they add new buildings, more square footage, just apply that price per square foot. We do the rest. As they scale down, we just had an organization close a third of their worldwide offices because they're contracting a bit. As they scale down, we retrieve that equipment and lower the costs, right? So it still gives that scale up, scale down type of capability. The other option, which I actually love, but I think since we're the only ones doing it, I think there's some market maturity that needs to happen before we see some wide-scale use of this, is more of a user-based consumption model, where it's purely based on, well, not purely based, but it's based on the number of entity users, right? The users of the organization. If it's a higher ed, student, staff, faculty. If it's a enterprise, it'd be the number of their employees or contractors that are connected in the network. If it's hospitality, it's the number of guests that are using the network, et cetera. But it's the number of their specific users that are using the network on a monthly basis. At the end of the month, we'll calculate the total number of unique users and provide a charge for that, Now, customers love that because that brings back that as a service type of construct I was talking about before, where it's purely based on your usage. As the business is performing better and they're growing and they're using more, they should expect to pay more. If the business is contracting, right, or less users are using the network, they should expect to pay less. Higher ed really loves this because we have a number of, unfortunately, higher ed institutions that have declining enrollment, for the past 3, 4, 5 years, but their IT spend hasn't changed, right? That math doesn't make sense for their CFO, right? But with our solution, ultimately they can align their spend to their enrollment, right? Which is really advantageous for them. Now, we've had a number of institutions buy into that. They love it, but they have to be able to, predict their usage patterns so they can start to predict what their budgets are going to be, which some organizations can do. Some organizations might not be ready for it. So we have organizations that are opting for that simple, predictable square footage based model, right? Want to monitor their utilization and then maybe opt in to the more true consumption based model at a later date.
Wow. It's simple. It very much is in line with the whole as a service thing. It's really the choice of the customer whether they want to do square footage or per person.
Yep.
And makes it very, very predictable.
Yep.
That's awesome. So how about POVs? How does a customer that wants to try this out, is that something that's offered? Is that something that, how does that look?
Michael, why don't you take this one?
Yeah, sure. There's two different offerings here. What we do is a proof of concept and I guess it's a pilot, right? Those are two different camps. I actually have a funny story about that. I'll get into it in a second. But if a customer is interested in, usually the request is we need to make sure that this networking stack that Nile's offering is going to play friendly in our environment. So
Right.
they'll do a proof of concept that involves bringing some equipment on site where they can test out. Usually they'll have the two big ones actually the biggest one is the authentication policies that they may already have. So they want to connect it to their existing Radius server, and then validate that their common devices can connect into the network and make sure those things work. Ironically, shipping the equipment, pulling it out of the box, racking and stacking it, and configuring it is much faster than watching the guy on the Radius server now integrate that and configure the policies. Every time it's like that. And every Radius system I've seen like the two big ones. It's like this treasure map that they have to hunt through. But anyway, once we get past that, everything is basically downhill from there because it's like, oh, can I add a new segment? Can I do this? Can I do that? Yes. It's always integrated into contextual services. Like, let me get the DHCP guy on the phone, and he rarely creates these subnets, and then when he does, there they go. And then there's this concept of a pilot where we've recently been requested to do this, where it's kind of like the system is like live running, where we'll go. There's an institution we're working with now. They've said we want to run a pilot for the IT staff. It's like the northwest corner of this building. We're going to replace the current access points and the switches with the Nile stuff, and we'll see how it works, and then we'll expand from there. And when it's running in a pilot mode, all the bells and whistles are turned on. So, we had this one customer that we marked them in the system as running a pilot, but they were really running as a proof of concept. And what happens is in the background, we have these things called soft bots. So I just call them robots. And the way that they act, they're pretty paranoid, right? They see some problem, a needle in the haystack kind of problem that would blip by a human. They latch onto it, and they'll do like what engineers do today. They'll open a TAC case. They'll okay, now send me the logs. Okay, here's the show log. Here's the config and all that. Here's the network diagram. And then maybe by the end of the week you get on a conference call to discuss with the engineer. And then that goes nowhere, and you got to escalate. Well, what these robots do is they have all the config already. They have the diagram because it was built by them, by us. And they'll open like a Slack channel, get a couple engineers in there, and they'll start working on the problem. And what happened was, this guy he didn't plug in both power supplies. He only had one in. So what happens is that's an alarm because it's mandatory, it's forced redundancy on our systems. So here's this alarm going off, and the robot basically sees this and says, hey, you got to plug this thing in. So it's annoying me. It's annoying these engineers, and they're like, hey, Mike, can you tell this customer to plug in the second power supply? And I'm reaching out to the guy. Eventually this robot starts seeing that the case has been open for so long and starts including, the engineering manager and all this stuff. So that whole escalation process is built in. And it turns out we're like, oh, this is not a pilot. This is a proof of concept. So we just adjust that in the back of the system. What happens is the robots kind of calm down, and I should really start calling them soft bots because apparently out in California and the Bay Area, they don't like the term robots. So
I keep thinking that movie with Will Smith there, iRobot. They're coming in and plugging stuff in.
Yeah.
But I think that's awesome because you again, and this is you in order to get the automation here that you need. And there's more stuff that I know that you guys are doing. We didn't even talk about the sensors, and I wish we had time. We'll have to come back to that. I think maybe we can do a whole episode on that. But like the sensors that you guys use to gather the information, the soft bots that you're using that are just paranoid and constantly looking at all those pieces there, the self-healing aspects, the opening tickets, bringing in engineers, all that automation process is it's maybe, I don't want to say it's not possible because I'm sure there's a way for someone to do it, but it's going to be a hell of a lot harder than doing it this way, the way you guys have with really just taking complete control over the software, the hardware, the protocols that are allowed. And I love that you call it the Nile Service Block because that's the only way that you're able to do this. If you have complete control over it, and then because of that, you're able to put in those automations, put in the SLAs. That's huge. The fact that there's financial penalties for you guys if the network on a customer's location is down or having issues or not built to the specifications that they need, like you guys have the financial incentives to make sure it's done right. And I think it was Scott at that meeting that mentioned the story about they were deploying something. I think it was for a pilot or for an implementation, and the guy's like, "Oh no, I forgot about the transceivers," and Scott was like, "No, there's you didn't. It's good. Like we got everything. It's all there. You're not going through a huge bill of materials, making sure I have enough power supplies. Do I have the right cords? Do they plug into the right? Do they plug into the right port on the PDU? Transceivers, all that gone." And it just makes it simple as the whole as a service piece should be.
Absolutely.
This is awesome.
Absolutely. If you're a network engineer listening to this podcast in the car or whatever, I want you to understand no more spreadsheets. You should know what that means. and Bryan, one last point. You made this point to build a system like this. If someone were to do this, like some large enterprise, they were to build a system that had all this automation, this kind of self-healing, all that stuff with the sensors, they could build it, but it would only work in that environment because it goes back to that snowflake thing where, it's just, these environments are totally different, and to get that stuff to work in their environment, it'd be.
And by the way, it would only work in that environment until one of the multitude of vendors that they use to put together that environment changed something.
Changed
in their
one
CLI,
thing.
their API, their whatever.
Yeah. And all network engineers listen to this. They have, understand that the customer that Austin mentioned before. This is a public institution. This guy publishes his MRTG graphs like online. Anyone can access it. This guy, he's got 30,000 like wireless devices on his network. And it's like, as a network engineer, I'm like, if a network like this doesn't exist, the one that Nile's describing, and I don't adopt it in the next 5 years, like, how am I I'm in trouble. Because I think, the automation story about like, just look in the cockpit of a plane. There's so many buttons and what they've done to solve that is, automation. Last time you were on a plane, the pilot didn't fly. Takeoff and landing, he flew. But in the air, the pilot did not fly that plane. And the reason why is humans can't, it's too complex. It's just too complex. So autopilot kicks in, and I think by law, they're not allowed to really override that stuff.
It's more than that, dude. I've been on this kick lately of watching a ton of these videos. I wish I remember the name of the guy, but it's like Airline Mentor or Airplane Mentor on YouTube. He makes these awesomely produced videos that like are just great, all about like various incidences and crashes and stuff. And he really goes into every aspect of it. And to your point,
Brian,
autopilot is still on.
Brian, before you continue,
Yeah.
I am deathly afraid of flying. So if this is something that's
No.
exaggerated my fear.
No. But to your point, like even like especially in the airplanes, right? With the fly by wire, under most circumstances, even when autopilot is off, there is still something there that's adjusting things, right? That was actually why the Miracle on the Hudson with Sully Sullenberger. He should have actually been able to land that plane softer, but because they had not disabled a particular system, the computer would not let him flare out higher than as high as he wanted to. If he had full manual control, he could have flared out higher and came to a much softer landing and not broken the aft section of the plane. But the computer intervened because out of a level of protection to keep it from flaring too high to avoid a stall. So it's always there. I don't know why we got off on that, but yeah, I've been on a kick with that, and I got a buddy of mine over at Pratt & Whitney. We were talking about engines and planes.
Great, I'm not going to be thinking about that all day.
Sorry. My apologies to the audience, but no, this has been awesome. I mean, I there's still so much that we could talk about, and I know like Mike and I have been talking back and forth, and we get into these discussions, and I'm like, dude, this podcast is going to go over, but this has been awesome. I want to thank you both. Want to give you guys a chance to share any final thoughts, last minute commentary. Michael, I'll start with you, and then I'll go to you, Austin.
No. Thanks for the opportunity to speak with you guys. Hope we get to do it again soon.
Definitely.
The one last thing I had in my thought was this. We were talking about the automation. What enterprises now are doing is they're starting to invest in these like DevOps organizations and whatnot. And in my experience, just from what I've seen, is when you take a couple really good network engineers and you move them into DevOps, they stay there. You never reclaim those resources. They write these automation platforms, and then they just iteratively keep building on them, and you've kind of lost those network engineers. So it kind of goes back to the point. It's like, if a network like Nile isn't successful, I'm in trouble. That should be my T-shirt.
I like that. Have those made.
Yeah.
Thanks, Michael. And Austin, you?
Yeah, I think, Brian, by the way, first off, thanks to you for pulling this together. This has been great. Really engaging conversation. I love the structure of this. Looking forward to hearing the feedback from, your audience, and looking forward to the next one.
Yeah.
I think to your point about, the visibility, really want to get into that once customers see or users see, what the experience is of how you interact, with the Nile service to build, your use cases, customers' use cases on top of that, how you support users and devices, all the proactive and reactive visibility we've kind of built into this. All of the concepts we talked about today, are further solidified, right? I think I would probably want to leave, the audience with, this thought, and we've touched on it a couple of times throughout this presentation, is that, listen, the last 3 decades, networking fundamentally hasn't changed, right? There's been new protocols, new features, new capabilities, new products, new approaches, but it's just complexity on top of complexity, right? And ultimately, something's got to give at some point, right? It's not just adding more complexity and cost on top of the existing complexity and cost. Ultimately, businesses are suffering. I fundamentally believe that most network engineers, don't want to be stuck in CLI and doing bug scrubs, running through the spreadsheets that Mike talked about, trying to figure out, can they patch, when can they patch, can they upgrade, can they take advantage of this feature, that feature, what's the latest validated reference design guide, what's the latest hardening guide, et cetera. Hey, can I get budgets to refresh, to upgrade my network, to bring more interoperability, more performance? Can I afford this level of redundancy or not? Can I afford to upgrade the switch stack or not? And then all of a sudden these IT business initiatives are not slowing, and I can't, properly, deliver an outcome that the business expects because, we never have enough people, never enough budgets. Ultimately, cloud has proved, IaaS, PaaS, and SaaS has proved there's a better way, right? Elevate our thinking, elevate our approach to get out of all of that burden, and I don't have a better word other than burden, right? And instead refocus our time and effort and our budgets and our resources to delivering the right outcomes for the business, right? While getting rid of, the monotony of just doing that endless, patching, tuning, optimizing, of the network stack that we've been doing for the last 3 decades.
I couldn't have said it any better myself, Austin. I think that's spot on. You didn't even touch upon what happens when it breaks, and is the support contract up to date, and what level of support can I afford?
Stuff, yeah.
That's a whole. But it's there. It's a complexity and it's a burden. So, that's great. Gentlemen, I really appreciate you coming on today. This has been great. We'll definitely have you on again. We'll talk some more about various things, but thank you again for coming on, and thank you for listening or watching the show on YouTube. If you've made it this far, first of all, God bless you. This is definitely the longest episode we've done, but definitely a lot of fun. Appreciate you being on with us, and we've got some cool stuff coming. But one of the cool features that we're doing now is, as I've said many times in the past before, if there's something that was interesting, reach out to your local account team. Well, that's different now in my new position. You can actually reach out directly to me, and we've actually formed a Discord server to be able to continue this conversation. So we're looking to get fellow network engineers, et cetera, from around the world to come into this Discord channel and just talk about either the episode, trends in the technology, things that or you're seeing in your environment, and just keep the conversation flowing. So discord.conft.show. We're just getting it up and running, so if you see there's only a few people on there, that's why. But please continue the conversation, join the conversation, reach out if you have any questions about this or any of the other technologies we talk about. Until next time, stay safe out there, and don't forget to save that config.